Modern vehicles are equipped with advanced electronic control systems that depend on a network of sensors to operate efficiently, safely, and in compliance with emission regulations. These sensors serve as the primary data inputs for the engine control unit, commonly known as the ECU. When even a single critical sensor fails, the result can be reduced engine performance, poor fuel economy, increased exhaust emissions, or, in severe cases, a complete no-start condition. In this tutorial, we will examine 5 of the most important engine-related sensors, focusing on their function, typical location, and common failure symptoms. Before we begin, be sure to subscribe to the channel, like this video, and watch through to the end for additional learning resources. Let us get started. 1. Oxygen Sensor, O sensor. The oxygen sensor monitors the oxygen content in the exhaust stream. This information allows the ECU to continuously adjust the air-fuel mixture for optimal combustion efficiency and proper catalytic converter operation. Most vehicles use both upstream and downstream oxygen sensors. Common failure symptoms include an illuminated check engine light, diagnostic trouble codes indicating rich or lean conditions, poor fuel economy, and failed emissions tests. 2. Mass Airflow Sensor, MAF. Located between the air filter and the throttle body, the mass airflow sensor precisely measures the amount of air entering the engine. This measurement is a primary input for calculating fuel injector pulse width. Contamination from dirt or oil is a frequent cause of failure. A faulty MAF sensor may result in rough idle, hesitation during acceleration, engine stalling, and abnormal fuel trim values. 3. Engine Coolant Temperature Sensor, ECT. The engine coolant temperature sensor is a thermistor that provides the ECU with accurate engine temperature data. The ECU uses this information to manage cold start fuel enrichment, ignition timing, and cooling fan operation. When this sensor fails, often reporting a constant cold or hot condition, it can cause poor cold drivability, overheating, improper fuel delivery, and a check engine warning. 4. Throttle Position Sensor, TPS. The throttle position sensor is a potentiometer mounted to the throttle shaft. It produces a voltage signal proportional to throttle opening, allowing the ECU to determine driver demand. This input affects fuel delivery, ignition timing, and automatic transmission shift strategy. A faulty TPS, typically showing erratic signals or dead spots, can lead to hesitation, surging, unstable idle, and harsh or delayed gear shifts. 5. Manifold Absolute Pressure Sensor, MAP. The MAP sensor measures absolute pressure inside the intake manifold, enabling the ECU to calculate engine load. The difference between atmospheric pressure and manifold pressure reflects engine vacuum. In many systems, the MAP sensor works alongside or in place of a MAF sensor. Failure symptoms often include poor performance, rough idle, excessive exhaust smoke, and drivability issues similar to MAF-related faults. These 5 sensors form the foundation of the engine's electronic sensing network. Understanding their operation and failure characteristics allows for faster, more accurate diagnostics and repairs. Thanks for watching. Like, share, and subscribe for more in-depth automotive tutorials and expert insights.